In this video, I'm going to show you how to draw a tangent line of an inverse sine graph. So we want to draw a tangent line at A. So let me just show you in Desmos. So as you slide A back and forth, it will draw the tangent line on the inverse sine graph. So let's try and do it. So if we want to know the equation of the tangent line, well, any straight line would be of the form y equals mx plus c. We need to know the gradient and the intercept. So to find the gradient, we would need to differentiate this. So our first task is to find dy by dx. So we need to differentiate this. So to differentiate this, so start out with sine inverse sine of x. So from here, you sine equally to both sides. So you sine this side and then you sine this side. That will then give you this. And when you sine an inverse sine, they will undo each other, giving you just x. And on this side, it's going to be sine y. So that would then take you to here. So when you come to do this, just imagine this in your mind. When it comes to this, don't write it down. Just have it in your mind, but when you come to write it, just jump straight to here. So when you sine equally to both sides, it will then take you to here. So from here, you would need to use implicit differentiation. So imagine this as being a bubble. So now use implicit differentiation. When you differentiate this, it would be cos the bubble. So it would be cos the bubble, and then times the derivative of the bubble itself, which is dy by dx. So I'll require you to understand implicit differentiation. So that will then take you to here. And then when you differentiate this, it would just become 1. So now you want to get dy by dx on its own. So divide both sides by cos y. So this is your answer. This is acceptable. But we don't want the answer in terms of y. So we need to go back to here. We need to go back to here. And then we need to translate cos y. We don't want the answer in terms of y. We want everything in terms of x. So go back to here. Create a triangle, a right angle triangle, in such a way that this thing will be true. So if we create a right angle triangle, you always sine the angle. So let y be the angle, and sine is this thing here. So if I make this to be x, and this and the hypotenuse to be 1, then given this triangle, if you sine the angle, that equals x over 1. That equals x over 1, which is x. So you can see that this is true. This is true. So create your triangle in such a way that create your triangle in such a way that this thing will be true. And we've just created it. It's this triangle here. So now we can translate y, cos of y. Well, cos of y is this thing here. So cos of y equals, if this length, if the hypotenuse is 1 and the adjacent, the opposite is x, then we can use Pythagoras to work this out. So let's call this w. So we know from Pythagoras 1 squared equals x squared plus w squared. We're trying to work out w. We're trying to work out this length. So now this thing here is 1. So now take away x squared from both sides. So that will then give us this, and then square root both sides. That will then give us this. So this length here, this length w, is actually square root 1 minus x squared. So let me erase this. This length is actually square root 1 minus x squared. So let me erase this. Hang on. So now we are here. We are here at the moment, and we need to translate cos of y. Well, cos of y is this thing here. Cos of y is this thing here. So cos y equals adjacent over hypotenuse, adjacent over hypotenuse, which just collapses down to this thing here, divided by 1. It's the same thing. So cos y is actually square root, is this block here. We can then put this block into here. That will then give us this thing here. So when you differentiate it, dy by dx equals 1 over square root 1 minus x squared. So let's go back to the beginning. we are trying to work out the gradient of this. So so when you differentiate it, it gives you, when you differentiate it, when you differentiate this, it will then give you this. So this thing here allows us to work out the gradient anywhere along this line. We can work out the gradient anywhere along this graph. But the thing is, we want it precisely at A. So we need to evaluate this at precisely A. So if we want to know the gradient right here, we will need to put A into here. So hang on. This thing here allows us to work out the gradient anywhere along here. But because we want to know the gradient right here, we need to evaluate it at A. So evaluating at A, you put A into here. So that will then take it to here. So the gradient right here is given by this thing here. So now we know the gradient at that point, so we can put it into the M. So that will then give us this thing here. So don't forget, the x gets multiplied to the top. So that's why it's at the top. So that will then take us to here. This is the equation of our tangent line. But the thing is, we still need to know the intercept. We still need to know the intercept here. To work out the intercept, you need one particular point on the line. Well, we know one particular point is here. It's at A, comma, inverse sine of A. So these are the coordinates at this precise point. So this is your x coordinate. This is your y coordinate. So you can put this into the y. That will then give you this. You can put this into the x. That will then give you this. And then work backwards to find c. So at the moment you've got one block equals this block plus this block. If you want c to be on its own, you would take away the middle block. You would take away this block. So that will then give you this. So now we've got an intercept. Our intercept is this thing here. So we can put that back into the C. So the equation of our tangent line will be given by this thing here. So if you punch this into Desmos, which will then give you this thing here, that will then give you this thing here. Well, punch in your graph. This is your graph here, and then punch in your point. Your point is right here. This is your point here. Hang on, that's your point. As you move it, it will work out the gradient at any given point, and it will work out the intercept. From there, it will draw the tangent line. Okay. So just notice that when A is precisely 1, you can't. There is no gradient because it's vertical. This bit here is vertical. When it's vertical, you can't have a gradient. Anyway, the tangent line is given by this. Okay.